Now, we talked a little bit about modeling, quantitative modeling, when we discussed this engineering analysis, trying to analyze the problem. And in many cases, those same models that we built to analyze the problem also help us test different solutions and try to quantify which solutions provide a better improvement of a KPI or are able to deliver a particular result or goal. So we're going to come once again, to this model of the Bunker Hill Cafe and try to build a model that tracks the movement and accumulation of stuff over time. The stuff that we're going to be caring about is the goods, so all the products, the food products, the drinks, snacks, sandwiches, whatever, that move physically through our cafe space. We're of course going to track money that enters the business, money that leaves the business, as well as track people and labor. How much time is spent working in these cafes, helping customers, doing inventory and maintenance, so on and so forth. These three categories, goods, money, and people or labor, are quite common stuff that we track in these quantitative models. As you build other models for different for different projects, for different solutions and problems, you might include different categories, but quite often we look at these three categories of stuff at a minimum: materials, money, and people. We first begin in building this model with trying to create a visual diagram that helps map out where all the stuff's going, how do they move, and sort of what categories do we need to measure and quantify. So first, we'll create a little flow diagram here with the Bunker Hill Cafe in the center. We'll also create a little box that indicates our workers and the movement of goods, money, and labor from the worker to the cafe. We'll also create a little box indicating the supplier, so the person or the organization that manufactures and produces the food that the cafe sells. And of course, the customer, the students who purchase the goods, who create a demand for customer service, who of course pay money as revenue. So for each of these three categories, goods, money, and people or labor, we're going to track the flow of these things through these four different parties, through these four different little boxes. In terms of goods, our supplier physically sends or delivers sandwiches or other food products, and those sandwiches are eventually sold and passed on to the customer. For each of these flows, we want to ensure that anything that enters the system is able to leave that system at essentially the same rate. And so any sandwich that comes to the cafe has to be sold by the cafe to the customer. We don't want the amount of sandwiches delivered to be dramatically greater than the amount of sandwiches sold. We also probably don't want to have a shortage of sandwiches, in which there are more sandwiches that will need to be purchased than ones that we have in inventory. We want to match the flow of stuff, sandwiches in, sandwiches out of this cafe. We of course track money, and the same sort of idea that the customer pays money to the cafe, and the cafe has to pay money to the supplier for the sandwiches and also pay salary to the worker for their labor. And then finally, in terms of labor or people that need to be at the cafe working, these workers contribute so many hours of their labor. We often represent this in units of person hours. So one person working for an hour is 1 person hour. You could also have 2 people working for half an hour each is equivalent to also 1 person hour, a common way in which we quantify labor. The cafe also has maintenance, so people have to do inventory, clean up a little bit, and so that creates another flow of labor here within the cafe. And of course, our workers have to help check out, service, answer questions from our customers, until there's a flow of labor from the cafe back to the customer. For each of these things, we map out this because it tells us what do we need to model, what do we need to create an equation for. For each of these three categories, goods, money, and labor, we need to track the flow of stuff. We need to see how much is entering, how much is leaving, how much is accumulating. Ideally, we would have an equal inflow and outflow of sandwiches. We don't want to accumulate any sandwiches. We have an equal inflow and outflow of labor. We don't want to accumulate any excess labor or sort of people just standing around not working. But we may want to accumulate a net amount of money. We have more revenue coming in than we have the cost of goods or salary leaving. Our model is going to try to track each of these things so we can measure how much is flowing and how much is accumulating for these three categories of stuff. I would encourage you to, one, make sure that you've practiced our Excel homework, our problem set from the previous week. Excel, again, is a quite useful, very ubiquitous tool in engineering, and you want to make sure that you're very well versed or getting more familiar with this particular tool. I've built a model in Excel, which we're going to take a look at in a second, and I encourage you to pour through it and look through the different equations, the way that this model is set up, to get an idea of how you might use a computational program like Excel to track the flow of all these different parameters and ultimately use it to reveal some insights, which we'll talk about in a moment. So we're going to move to our Excel model here in our next short little video.